Central tendency. Central tendency refers to a statistical concept used to describe the center or typical value of a dataset. It provides a way to summarize and understand the distribution of data points by identifying a single representative value around which the data tends to cluster. Central tendency. Mean, the arithmetic average of all values in the dataset. It is calculated by adding up all the values and dividing by the total number of values. Median, the middle value when the data is arranged in ascending or descending order. It divides the data into two equal halves, with half of the values falling below and half above the median. Mode, the most frequently occurring value in the dataset. A dataset can have one mode, unimodal, two modes, bimodal, or more than two modes, multimodal.
What is mean in statistics? Mean is commonly known as average. For example, if we say, the average height of the class of students of grade 9 is 150 centimeters, then it means that the mean of their heights is 150 centimeters. Mean is a statistical concept that carries a major significance in finance and is used in various financial fields in business valuation. Mean, median, and mode are the three statistical measures of the central tendency of data. What is arithmetic mean? Arithmetic mean is often referred to as the mean or arithmetic average. It is calculated by adding all the numbers in a given data set and then dividing it by the total number of items within that set. The arithmetic mean, AM, for evenly distributed numbers is equal to the middlemost number. Further, the AM is calculated using numerous methods, which is based on the amount of the data and the distribution of the data. An arithmetic median is a positional average and refers to the middle value in a distribution. It divides the series into two halves by first arranging the items in ascending or descending order of magnitude and then locating the middle value and is denoted by the symbol x tilde or am. The arithmetic mode refers to the most frequently occurring value in the dataset. In other words, modal value has the highest frequency associated with it. The mode is the value that appears most frequently in a dataset. A set of data may have one mode, more than one mode, or no mode at all. Other popular measures of central tendency include the mean, or the average of a set, and the median, the middle value in a set. How do I calculate the mode? Calculating the mode is fairly straightforward. Place all numbers in a given set in order. This can be from lowest to highest or highest to lowest, and then count how many times each number appears in the set. The one that appears the most is the mode. The geometric mean for a series of numbers is calculated by taking the product of these numbers and raising it to the inverse of the length of the series. The geometric mean is best used to calculate the average of a series of data where each item has some relationship to the others. That's because the formula takes into account serial correlation. This sort of relationship can be found with portfolio returns, bond yields, and total returns on equities. Earnings and compounding represent that correlation. They affect the return for each succeeding period measured. Geometric mean accounts for that impact. The geometric mean is considered to provide a more accurate idea of average return than a mean calculated simply by dividing a sum of items in a data set by the number of items.
Mean 1. It can be easily calculated, and can be easily understood. It is the reason that it is the most used measure of central tendency. 2. As every item is taken in calculation, it is affected by every item. 3. As the mathematical formula is rigid one, therefore the result remains the same. 4. Fluctuations are minimum for this measure of central tendency when repeated samples are taken from one and the same population. 5. It can further be subjected to algebraic treatment,
unlike other measures, that is mode and median. 6. AM has also a plus point, being a calculated quantity, and is not based on position of terms in a series. 7. As it is rigidly defined, it is mostly used for comparing the various issues. Demerits of arithmetic mean 1. Affected by extreme values. Extreme values have an undue influence on the arithmetic average because it is calculated from all the values in the series, whether they are very small or very large. 2. Assumption in the case of open-end classes. It is impossible in the case of open-end classes to calculate the arithmetic mean without making an assumption about the magnitude of the class. 3. Absurd results. Arithmetic mean can sometimes provide results that appear absurd. For instance, If the average number of students in the school in a particular class and a particular section comes out to be 15.6, then the result average is absurd as children cannot be divided into fractions. 4. Not possible in the case of qualitative characteristics. Arithmetic mean cannot be computed for qualitative data, such as data on IQ, beauty, honesty, etc. The only appropriate average in this case is the median. 5. More stress on items of higher value. The arithmetic mean places more emphasis on higher items in a series than it does on lower items. This means that it has an upward bias. If 3 out of 4 items have small values and 1 is quite big, the average will be significantly increased by the big value. However, the opposite is untrue. If a series of 4 items consists of 3 items with large values and 1 item with a small value, the arithmetic average will not be significantly decreased. Merits of geometric mean: it is rigidly defined. It is based on all the observations of the series. It is suitable for measuring the relative changes. It gives more weights to the small values and less weights to the large values. It is used in averaging the ratios, percentages, and in determining the rate gradual increase and decrease. It is capable of further algebraic treatment. As such, if the GM and the number of items of 2 or more series are given, we can readily find out the combined GM of all the series by the following formula: G1, 2 equal sign AL, N1 log, G1 plus N2 log, G2/N1 plus N2. For example, see the illustration 54. Demerits of geometric mean. It is not easy to understand by a man of ordinary prudence as it involves logarithmic operations. As such, it is not popular like that of arithmetic average. It is difficult to calculate as it involves finding out of the root of the products of certain values either directly or through logarithmic operations. It cannot be calculated if the number of negative values is odd. It cannot be calculated if any value of a series is 0. At times it gives a value which may not be found in the series and may even be assured or impracticable.